Earth is the third planet from the Sun. It has the right temperature, liquid water, and breathable air to support life. When we walk outside, we operate on a very basic assumption. The ground beneath our feet is completely solid, static, and permanent. Then the ground shakes, or a mountain tears open. Earthquakes and volcanic eruptions quickly shatter that sense of stability. These violent events prove that the surface we stand on is merely a wrapper, hiding a chaotic, highly active interior. To truly understand the world we live on, we have to abandon the idea of a solid Earth and dive directly into its hidden depths. Our descent begins at the crust. It's the outermost physical layer of rock and soil where we actually live. Looking at a full Earth cross-section reveals its extreme thinness. The crust is a razor-thin boundary line. Zooming in shows two types: the thicker continental crust forming landmasses and the thinner oceanic crust beneath the water. Even though it holds vast oceans and towering mountain ranges, this layer is a remarkably delicate shell. Every human civilization, every deep-sea trench, and living organism in history exists entirely on this fragile skin. Dropping directly beneath the crust brings us to the mantle. This massive band is by far the Earth's thickest layer. At this depth, extreme heat changes rock into semi-solid magma. This magma constantly churns in massive, slow-moving loops. Rising currents scrape the crust's underside, physically dragging the tectonic plates. The mantle acts as a massive, hidden internal engine whose churning dictates the shape and location of our continents. Pushing even deeper through thousands of miles of churning rock, we arrive at the deepest part of the planet, the core. Down here, the composition shifts away from rock into a heavy, incredibly dense concentration of iron and nickel. Focusing on the center of our cross-section, the core is split in two. The outer core's extreme heat melts the metals into a liquid state. Right in the middle, crushing pressure forces the incredibly hot inner core to remain completely solid. At the center of our habitable world lies a heart of solid metal, burning at unimaginable temperatures. Rushing back up to the surface reveals how these distinct zones interact. They operate together as a single dynamic machine. The intense heat radiating from the core warms the thick mantle. That heat churns the magma, and those moving currents crack and push the thin crust we stand on. This deeply interconnected system is the hidden mechanism causing the earthquakes and volcanoes that disrupt our surface. While those geological events can be destructive, they serve as vital proof that our planet is geologically active. The extreme, uninhabitable layers beneath our feet provide the exact mechanical forces required to maintain the life-supporting crust we call home.